Thank you very much for coming and joining us this afternoon for this webinar. As you can see, the title is Generating Deliverables from Point Cloud Data in Trimble RealWorks and Trimble Business Center. The Trimble RealWorks, I'm going to cover Trimble RealWorks first. It's going to be for more underground mine scans or ore drives or development, not really stoping. It's more for all your board and pillar style mines where there's a lot of development work and you're busy scanning forward. It's not for when you're scanning stoping or sending in autonomous scanners into a stoping environment. You're looking for ore dilutions and volumetrics. So for the agenda today, I'm just going to give you a quick introduction, which I'm kind of busy with. Then we're going to go onto the underground scans in RealWorks. It'll just be overview, looking at a scan, what can you do in RealWorks once you have a scan done. It may be georeferenced or not. I'm not going to cover georeferencing in this webinar. Generally, georeferencing happens in a different software. Obviously, Trimble RealWorks is fully capable of georeferencing any scan data, whether it being above ground, underground, any form of data. If you have features that are identifiable with real world coordinates, you can very easily georeference them. But in our scenario today, we're going to assume that we're working on a local coordinate system for our scan. We're then going to run through some basic operations, slicing the scan, doing some 2D line work, sampling down the data, creating meshes, calculating volumes of workings. Then we'll move on to surface scans in TBC. So I'm not going to focus on any tunneling stuff in TBC in this webinar. It's primarily going to be the point clouds tab. So it's going to be taking a point cloud, classifying it into different regions, be it vegetation, ground, buildings, and then working with a feature library to use the classified point cloud regions to create deliverables such as a drawing, basically a standard CAD drawing. We won't go into the drafting aspect, which is the putting a frame. I do have the project open on my computer, so once we've run through everything, I'm going to make sure I leave enough time at the end. If you have any questions, I can open that and share my screen and we can play around a little bit. If you have some further questions for me, that will be in the Q&A, and then the social media, all the social media links and everything. So introduction, a little bit about me. That's me, Michael Harrison. I'm sure a lot of you have met me by now. If you haven't, I'm the product portfolio manager for reality capture at this stage. So basically, I look after all the laser scanning equipment or instruments inside of Optron Geospatial. I'm a professional land surveyor by trade or profession, registered with SAGC. I'm also a member of SAGG, but currently looking after the reality capture portfolio at Optron. So we're going to dive into the RealWorks part of the webinar. So here's our first slide. You're going to see the majority of the slides are going to look like this. It's just going to be a video that's going to play, and then I'm going to narrate the video as it's going. So here you can see this is an underground mining environment with all sorts of people moving around, machinery. I've trimmed it just to make it a nice neat square, just so it's easier to work with. Obviously, you're going to find all sorts of different scenarios and situations underground. But in this first video, what I'm doing is I'm just creating a cutting plane, and I'm taking a slice through the center, or the most general center I can, of these workings. You can see I'm looking now, I'm adjusting my plane. What I used there was a 3-point plane. You can see I chose a 3-point plane to select 3 points on my point cloud, and Trimble RealWorks defines the best fit plane through those 3 points. There's a number of different ways you can define a plane in RealWorks. Sorry guys, my computer just went black on me there for a second. So here you can see I've defined my slice now. So there's a number of ways to define your plane. You can make it parallel to the z-axis. You can make it parallel to the z, to the x, parallel to the y. You can ask RealWorks to calculate you a best fit plane, or there's a number of different ways, or you can do the 3-point plane like I've done. Once I've taken a slice, I've decided I want my slice to be 2 centimeters thick. So we've created our slice using this. We're now going to take our slice and create a 2D line of our underground working. So you can see there, I manually removed all the noise within the scan and created my own layer in the cloud with it. I'm now selecting the 2D easy line drawing method. I've given my threshold for drawing 2 centimeters or 0.02 of a meter. I found this works best with point cloud data between 0.05 and 0.02. Anything bigger than that and it starts cutting corners, anything smaller than that and it starts drawing wiggly lines through any noise that might be existing in your point cloud. So now you can see I'm in the edit polyline function. So you can see I just said preview easy line and the software drew everything itself. I'm now just editing. You can see if there's any small gaps, you can see here I found there to be something funny. So I'm highlighting it and I'm selecting them and I'm removing them. You see now I'm selecting the 2D line. I'm drawing the line through there. You'll see here I turn on the cloud because I was interested to see why there was that noise there. And you can see, oh, there I realized I didn't clean that part of the cloud properly. This is me having a look. At this point now, I'm looking for corners that have been cut by my line drawing. You can see I'm going to zoom in. Oh, I see one there. So I see that this corner didn't land up where I wanted it. So now I'm just adjusting my 2D line. You can do this as much as you want, obviously. You can adjust the lines to fit your point cloud wherever it has made a gap, or yeah, this is basically just an example of what you can do. So I've decided this I want to bring down. So I'm adjusting this line. So here I'm just going to fill in this little hole. And now I'm going to highlight that little line that's sticking up there. All you have to do is fence it like that. And any line that is in that fence will be highlighted in red and can be removed. So now there, I'm thinking that's good enough. And I'm applying it. So I've created it. So there is my 2D line drawing of that section. So now it's important to note that this is now sitting in a local coordinate system. These lines are projected in the exact same system as the scan. So it is important to note that if you want these drawings to be sitting on the system of wherever you are working, it's important to georeference your scan first. So most of the time with something like SLAM data like this, once you've scanned, one of the processing steps is to georeference data before it comes into RealWorks. Obviously, you can very much georeference it as a step before the slicing step, but just keep that in mind. So now the next step, we're going to take the whole point cloud, and now we're going to run some classification just to. So I find I do this for a number of reasons. I like to classify my point cloud One, it separates the roof from the floors from the walls, and that's helpful for meshing and volumetrics. It also separates all the people moving around and the machinery and everything that isn't what we are looking to measure. It normally puts that in its own little point cloud region. So I'm running auto classify indoor. I found obviously we have tunnel indoor and outdoor. Depending on your application, different ones will work better. But I found in this particular point cloud indoor, it works pretty well with finding the ceiling. You can see here the green is the ceiling. It's classified graded floors, ceiling, walls, and remaining. So it shoved all the machinery and the conveyor belts and whatever wasn't cleaned up in the original processing of data, it shoved it into its little remaining. You can see here now. Obviously, some of the floor, wherever there's mud and water, it does also put it into the remaining point cloud. So there is potentially some cleaning up you have to do. So if I just look at this point cloud now, I can see that my ceiling is fine. My walls are okay, especially for if I'm going to be meshing this. There's small gaps, but generally I'm going to subsample my point cloud down before I mesh anyway. The floor, you can also, if there's gaps like that, you can trim out some of the remaining point cloud that it's classified into remaining that is floor and add it back into the graded floor or the floor layer. It's not always necessary, as I'll show you in this example coming up next. So what you haven't seen is what I did was I just merged the walls and the ceiling into one point cloud and the graded floor into, I left it as it is. So I've got you can see the gaps on the left. That was machinery lying down the one side of the workings. But as we know, with meshes, it does a triangular mesh through our points. So if there are small gaps, it's just going to mesh through them. So it's not completely critical to completely fill every single gap. And now we have the ceiling and the walls. This was a little bit more consistent of a cloud. Obviously, there was nothing in the way. So now I'm generating a mesh. So you can see now I have a mesh of the floor, walls, and ceiling. And now with this data, we can go ahead and move on to the next step, which is volume calcs, everybody's favorite. So in the past, especially working with RealWorks, one of the great things about RealWorks is it can do a volume between a point cloud and a point cloud or a surface and a surface. Whereas in other softwares, even TBC, you must have two surfaces to generate a volume. In RealWorks, I could have skipped the meshing step and gone straight into the volumetric step with my two sample down point clouds, or even my unsampled point clouds would even have been better. But there is a chance that the gaps, that these pillars in between the roads and the splits will be filled up by volume, and you have to manually remove it. In this method, I found that if you mesh everything first and then do a volume, which you'll see here. So here's our mesh. It's now gone from green to gray, but so what I'm doing now is I'm selecting both of my meshes, the floor and the ceiling. And this can be done with any scan data, whether it's terrestrial scan like a Trimble SX12, X7, X9, handheld SLAM scanner. Any point cloud data can be maneuvered like this, and you can see I selected the floor and then the roof column, the roof meshes, and I ran. And if you just have them selected, the software automatically knows to do a volume between the two instead of doing a volume between a surface and a plane. So this is me just saving the report so you can have a look at it. Once you've run your volume, you get a pretty little picture of the volume. You also get a little volume report that looks just like this. Gives you the area under volume and the volume itself. So now I'm creating the volume element itself and I'm closing. So you have an actual element in RealWorks that is your volume. You can inspect it. You can see if there's any gaps. It gives you a pretty little picture like that. You can see that has been, my resolution on this volume was 0.1 of a meter. So that means I used 0.1 by 0.1 vertical rectangles to estimate the volume of the entire cavity. So that was the RealWorks presentation, or the RealWorks calculations. We're now going to move on to TBC. This is an example of a scan I did, or some data that I had of a small section of road. You can see here I'm importing the feature library in the beginning. This can be done at any point, but it's just a small little stretch of road. This is a small part of a much bigger scan. I just used it so the processing went quickly. You can see now I'm running the point cloud classification, which is generally the first step in most of the point cloud stuff I do in TBC. I found it pretty useful. You can see I've selected outdoor aerial instead of outdoor terrestrial. The reason being, outdoor terrestrial TBC is looking for data from, for example, an X7 or SX12, more your traditional tripod-based lidars or laser scanners, and it does classify things slightly differently. But there will be issues in the classification. You can see there's a tree that the trunk has been classified as a light pole. You can see the red is light poles, the green are trees, blue is buildings, the walls and dividers are light blue. There's a bit of noise. You can see a little bit of the tree. So that's all stuff you have to clean up. But I found that outdoor aerial for SLAM data works best. So you can see here I am turning off all the layers besides the trees, because my the first thing I want to do with this data set is extract the trees. So I'm going to run the tree extraction module now. So I have only the trees turned on. Okay, this is me just doing a little bit of cleaning up work. So in TBC, just like RealWorks, you can select a piece of point cloud. In RealWorks, just tell it in or out. In TBC, you assign it to a new region. You can create a region and assign it there. You can see I'm just shoving in the default region, just pushing it away there. That's where all basically my scan noise goes. You can see there I've got a little bit more noise that I'm removing, just so it can speed up my tree extraction. Okay, so now at this point, I'm happy that the trees look good enough for me to run the extraction. So I'm going to extract point feature, and I'm going to extract a tree. You can see I'm going to select automatic. So you can manually click each tree trunk, and it will select that tree. You can then save the data about the tree, the trunk diameter, the spread, the height, and it will draw a tree pattern in the position in the center of the trunk for you. So you can see I'm just assigning a layer to it. Feature code. So this is the feature code library that I imported in the beginning. I am now giving it a code, and this has a number of attributes which will then be extracted from the point cloud. So now I'm just mapping the attributes. So tree spread, trunk diameter, and height. These are the three aspects of these trees that I'm interested in. So now I'm going to automatically extract the trees. Depending obviously on the size of the point cloud, it'll be quicker or slower. So now you can see it's found this many trees. And there is a way now you'll see me moving through. I'm pressing the forward and backwards buttons. And I'm ignoring trees that I don't think are trees. So I'm happy that being a tree. That one, don't think that's a tree. So I'm going to ignore it. Obviously, when all the canopies are touching, it does take a little bit of manual work to move your way through the trees. But the majority of these trees, this is also it's a SLAM data set, so the point cloud is nowhere near as crisp as it would be for a terrestrial Trimble scanner. Also, the purpose of the survey was to survey the road itself. So the trees were a byproduct. You can see I'm going through, and I'm reasonably happy with the trees as they are. Okay, I ignored that little one. And once I get to a point where I'm happy with all the trees, I'm going to run the extract tool, and I'm going to add 26 points. So it creates a CAD point in the middle of the pattern. You can see there it's drawn a pattern. The size of the pattern is scaled to the size of the spread of the tree. So it's not like, for example, in my private practice days when I was doing topographical surveys and drawing them on Model Maker, I would survey the tree, say it's small, medium, large, small, medium, and then scale my pattern to sort of what I thought it would be, and I would say in this drawing a small tree is this big, a big tree is this big, a medium tree is this big. So the TBC will draw the pattern the exact size of the spread. You can see now, so we've extracted our trees, we've got CAD points and the center of each one of our tree trunks with a pattern drawn already, and in the metadata of those points is the height, the trunk diameter, and the spread of every single tree. You can see now I'm running the light pole extraction. I'm just removing a little bit of noise here. And I'm also going to stick it in the default region. You can create your own point cloud regions. You don't have to use the default. This is just what I decided to use in this specific instance. So there we go. You can see these are the 4 light poles that existed in my little survey area. I'm also going to do it automatically, but this is quite a very simple one. And decide what layer utility elect was the layer I chose. And then I'm going to scroll down and look for a feature code which has the right attributes in it. So it's also important to remember this is a global features library that comes in with TBC when you install it. You can also create your own feature libraries. There's no rules. You can create whatever features you want. But anyway, I found the light pole feature and decided to use it. So all I wanted were these 2 mappings, the height and the diameter of the pole. So I'm extracting the poles, only 4, it's going to be pretty quick. So there you can see it found the 4 light poles. I'm just going to run through it just to make sure I'm happy with each one. Yep, I'm happy. And I'm going to add them and saying I'm going to add 4 more new points, and there it's added 4 new basically CAD points with a little pattern drawn for a light pole at the center, at the base of my light poles. So these will now be added to our CAD drawing. You'll see a little bit later on in my videos. So this is just building up. So we've scanned the road, we've just gone in and we've scanned, and now we're sort of using the point cloud data to generate basically drawing deliverables. So in this one, I'm going to be doing drawing the curbs, but automatically I'm going to use the curb extraction tool. So basically it's the line feature. We were using the point feature extraction beforehand. So now we're selecting curb and gutter. We're going to set our line up. I'm going to decide which layer I want to put it in. I'm going to create a new layer. I'm going to select roadway. So in this tool, you select a point above and below the curb, and it must be as perpendicular as possible to the direction of travel of the curb. You can see now it's going to give us a cutting view, and you can see there is our curb. You have to select 4 nodes, one at the beginning, the bottom and top, and end of the curb, just like I've done, and then tells you which way it's going to extract the curb. I'm going to extract every 5-meter intervals because it's quite a long stretch of curb. So now I'm extracting, and then now it's basically just drawing the curb line. And you can see here, you can see how the curb changes on my little slice view. So I'm going to apply auto templates, and that's just going to bring my curb back because the curb's getting smaller and smaller as it gets to the corner because it narrows down. This is also not a very well built curb by any means. It's quite a old road outside of Cape Town. So you can see there, got confused. So I'm going to undo that, and I'm going to change my, you can see now the curb's getting a bit smaller, so I'm going to change it now down to 0.5 of a meter, so it extracts in little bits, so it doesn't get to take it around the corner. And there you can see, okay, the curb is now basically flat. So I'm trying to auto template it to see if it'll keep going, but it's basically now a non-existent curb. So there, that's what you would do for drawing curbs using your point cloud data. So it's given you basically the edge of curb, bottom and top, and back of curb. So now I'm just creating these lines, and now these just become CAD lines in my plan view. You will see shortly we will go to the plan view. You can see there's our, so in the 3D view you can see the lines are drawn in 3D on the point cloud, but they also are, they can also be projected completely horizontally in a 2D plan. So I'm just now going to turn off, well, I'm turning on the different layers so everyone can have a look and see how my little plan is developing. So you can see there's my little topo plan. It's already developing quite nicely. Okay, so now the next workflow we're going to look at will be taking the extracted ground, subsampling it down, and generating some contouring. So yeah, I didn't mean to turn the ground off there. I'm going to turn it back on, and then I'm going to turn all the other CAD layers off, just so I'm working solely with the ground. So this is obviously the ground has come out of my feature extraction, or my point cloud classification, should I say. So I'm going to select the whole point cloud, and then I'm going to subsample it down, similar to what I did in the underground part of this in RealWorks. Very similar concepts, a spatial sampling of 0.5. I'm happy with that. So now it's going to create a new point cloud layer, a sample point cloud. There it is, a lot more sample down. You can obviously go a bit more than that. I mean, you can go to 1 meter, 2 meters. So importantly, you got to take your point cloud, which is one entity, and break it down into individual CAD points to create a surface that you can edit. This was a little bit of trial and error. So there you can see I used that little command to generate individual CAD points out of my subsample point cloud. I'm now going and I'm going to create a surface which you need to create your contouring. So I named the surface. Give it a color. It doesn't really make a difference. Just depends what you want to, how you want it to look. I'm going to classify it as built because it's a road as built. So I select all our points. So you can see there got 11,037 tacky shots essentially. So there's my triangle network. Obviously, as you know, you can edit the length, the maximum length of a triangle, so it just won't draw triangles between certain points, or you can just trim the ones that you don't want there. So you can see I'm just editing. I should have trimmed them a little bit better, but it was just for demonstration purposes that this tool works, although it will not trim a triangle as to leave a tacky point not connected anymore by 2 points. So it's important to remember that if you have an outlier point that it's drawing triangles to and you don't want the triangles to there, it's better just to delete the point than it is to try to delete the triangles. They'll never go anywhere. So now I've got my surface and I'm going to run a contour plan. So basically I'm making a contour interval of 2 meters. I mean, you guys have seen the data we've been working with. It's pretty flat, so it's not going to have a ton of contours, but 2 meters is a pretty standard interval. I'm putting my contours in a new layer.
So I'm just going to smooth the contours out, make them look a little better. Text style is basically your font. You can edit all of this in the drafting tab, but I'm going for a standard ISO. I like the way this text looks, but obviously everyone is different. I'm labeling every 10 meters between my contours, and you're not going to see very much, obviously, because there's not very many contours to see. But I'll turn off the surface and the points, and then you'll see the contours. With the text, the best way I've found to edit the text globally, so you can click on each individual text, so basically a contour label, and edit it. You can see that they sit along the contour line. I'm selecting it. You can move it. You can edit one at a time, like I'm doing here. Make it half as small. Or what you do is you're going to see here in this video, I'm going to select them all and edit them all at once. You can see I'm showing you how you can move them. Obviously, this is all stuff you can specify before you generate your contours, how they sit, which label only the ends, label along. So I've gone and selected all of it, and I'm just going to select a global height and width factor of our text. So there we've got contours. Obviously, you can also swap the triangles if they look like they're crossing curb lines. Obviously, as we know, draw the CAD first, and you can use the CAD lines of the curbs as break lines to stop triangles going through the break lines. All that sort of stuff generally applies. It applies exactly the same in TBC as it would in any other drafting package. So there's me turning it on. There's our little plan. You can put a grid on there, put a frame, put a little title block. Yeah, and that's it, guys. That's our little demonstration. So yeah, can I have a look? I'm gonna have a look at the chat now. First question that I see here, it's by Tessa. Tessa, does it extract toe and crests in an open pit? I think it does. Yeah. So what we're looking at is classification of your point cloud as a whole. So it'll extract the ground, but then you can run toe and crest lines. You can extract them as line features. I don't think it's going to automatically break your point cloud into toe and crest lines. The point cloud of the whole open pit benches will all be ground, and then you're going to have to then run lines along there. Ola, yes, the presentation was recorded. Individual CAD points in Trimble RealWorks? I don't think so. So in TBC, as you saw, I took the point cloud and broke it down into CAD points, which can then be exported into a CSV, into a DXF. In RealWorks, you're working with the point cloud as a whole. You can also export that point cloud as a DWG, where you can then extract the points. The latest version of TBC, Kweku, latest version of TBC, it just was released a few weeks ago, 2024. Yeah, version 5.9 2024, if I'm not correct. That's recently upgraded. It does have advanced. It allows you to train your point cloud classification, and mainly it's used for stockpiling. So I didn't touch on stockpiling here because it's mainly, most people are using UAVs and UAV data to calculate their stockpiles in TBC. I wanted to try go into a different, oh, there we go. I see someone posted a trial of TBC. Let's see, quick related for TBC. What are the export formats, Philippus? Are you talking about in TBC or RealWorks? So in both, you can export a large number of different formats of point clouds, of drawings. You can make a PDF drawing. You can export my drawing as a DWG, DXF. You can export all different point cloud formats, pod files, recap files. RealWorks especially exports a lot of different point clouds that can be read into all sorts of different point cloud and modeling software. Yeah, so Frida, there are trial versions of TBC and RealWorks you can get. It's for a month or 15 days, if I'm not mistaken. Magdalena, can you calculate tree volume? I guess you can. So generally, I know there is a formula, because when you do the tree extraction, you select at which height you would like the diameter of the trunk. And I set it in the example that I just did, I set it to 1.3 meters. And I think that's a standard that Mondi also used. But given the number of trees and the height and the thickness of the trunk at a certain height, you can calculate the biomass of a certain number of trees. But I think modeling up a single tree and calculating a volume, obviously it's possible. I can trim off all the branches and give you the volume of the trunk, but yeah, so I think the generally accepted way of doing it, I'm sure you might understand this, is it's LBH. I think it's breast height diameter. So normally it's about 1.3, 1.4 meters, the diameter of the trunk. Philibus, can you export a .lasd? I'm not actually sure what an LSD is. I know you can definitely export LAS files and LAS files and a large number of other point cloud files, but I'm not sure about a LASD. I must check for you. So Mote, ideally, what are the computer specs? So 32 gigs of RAM I find to be minimum for running point cloud stuff. I mean, you can get away a NVIDIA. We use NVIDIA GeForce RTX graphics cards. A good graphics card is quite important, especially when you want to view the point cloud stuff. So the running of the processing is more CPU taxing, but then when it comes to viewing, obviously then it gets more GPU taxing. So 16 to 32 gigs of RAM, a nice NVIDIA GeForce RTX graphics cards, what I'm using on this computer. This is not my computer, by the way, but I have the same graphics card. It's just I don't know what happened with mine. And then RAM, yeah, about 32 gigs of RAM as well. Kweku, no problem. Frida, have you ever encountered line steps in your DTM? When you say line steps, do you mean point clouds mismatching and then doing a surface between them, creating height errors? Tessa, can TBC please come up with auto break line extraction options for open pit point clouds? Yeah, so when it comes to the break lines, you have to have a CAD line already drawn, and then you can assign it as a break line for the surface modeling. But yeah, I do understand where you're coming from, auto break line extraction. Phylos, Trimble RealWorks a separate application, or is it directly integrated into Trimble Business Center? No, Phylos, Trimble RealWorks and Trimble Business Center are two separate softwares. A lot of the point cloud functionality from Trimble RealWorks has been integrated into TBC. The point cloud, a lot of the point cloud operations, the engine of viewing it's very similar. Trimble RealWorks has no projection plane when it comes to meshing surfaces that are not flat. So for TBC, for example, you can do surface meshes on the ground or the road or any sort of traditional survey surface where everything's sort of underneath one surface. But when you're underground and you have a tunnel or a stope, or anything where it's completely encapsulated by points, TBC will take that as one very noisy surface and try and mesh through it, whereas RealWorks, having the no projection plane, will be able to run a mesh around and generate a solid like you would in other software packages such as Deswick or MicroStation or stuff like that. So yeah, to answer your question, there's a lot of the point cloud functionality from RealWorks in Business Center, but there are one or two aspects of RealWorks that aren't in Business Center yet. Okay, so Erasto, in this presentation, I see you specifically identified and explained about scan data. So how about data captured manually by either GNS or Total Station? Well, yeah, so TBC is a great software for GNSS and Total Station data. So you can assume it, just like how I broke down the, so it's not going to do the point cloud classification, obviously, but you can use your GNSS data or your Total Station data exactly how you would in a package such as Model Maker. I'm referring to Model Maker because it was the software package I was working with before I joined Optron. You can do all your meshing, all your contour planning. You can label things. You can manually place the same little patterns that I was using for the trees and the light poles on your plan. You can use GNSS or Total Station data if you survey a stockpile to create a mesh and generate a volume. Obviously, it's just a lot sparser point cloud. For example, if you do a tacky survey of a piece of land with a Total Station, it's just, you can visualize it as a very subsample point cloud, maybe 5 by 5 meters. You can still work with that in TBC, no problem. For GNSS, also in TBC, it's very, very good with the post-processing. So you can take GNSS receivers and log static data. TBC handles post-processing of that data very well. And it's a very effective way of fixing very accurate control, especially over large projects. Thank you, Chris. On RealWorks, did you drop the point cloud to be flat, or is it the way it is? So I think you're referring to the floor. So what I did was the point cloud was this shape. It was underground board and pillar mining, and what I did was I extracted the ceiling and the roof. So the ceiling, walls, and floor. So the flat part of the point cloud is just the floor being extracted out of there. And then that's what I used to mesh the floor, and then I meshed the walls and the ceiling as one point cloud. I just merged them together. And then between those two surfaces, I was able to calculate volume in that void. No problem, Ellis. I see Gustav's answering you. File us there, 2 separate packages. Dave, yeah, TBC and RealWorks, very similar scan registration. It works basically the same. Now you can do the cloud to cloud stuff. I've used both to test. I've done 2 scans of 2 separate areas with about a 20% overlap in the middle, and I've tested in RealWorks and Business Center, and I get very, very similar results. Lloyd, it depends, Lloyd. It depends what you're trying to do with your point clouds. I think TBC is a very good one because it works if you're doing work above ground. TBC should be all you need. RealWorks, if you're doing underground work, it's also for modeling. So if you're going to be scanning buildings, it's something I didn't touch on in this webinar, just time constraints. If you're going to be scanning buildings or structures and you want to model that into IFC models and take that into Revit or SketchUp or Tekla or all those 3D BIM software packages, then RealWorks is more ahead of TBC in that. TBC is more almost focused towards your traditional survey, whereas if you want to start modeling buildings up into solids or pipeline, you can model pipes in RealWorks. You can model cable trays in factories. You can model steel beams up and you can take those as georeferenced scaled models and bring them into other modeling software where you can do designs, especially for the engineers out there. Phalos, I see you just got a question that came through there. Yes, if you've scanned, for example, one area and it's georeferenced and it's sitting on the right system and it's there, and then a week later you come and scan again and you overlap them, you can very much in TBC and RealWorks have this in a project, bring the scan into the project, and if there's enough overlap between the two, register that point cloud on, and it should be on the same system. Obviously, that is dangerous. The further on you go, you will start to experience drifts. So it's good to control your point cloud every now and then just to make sure that it's still heading in the right direction. Right, guys, I was going to, if I was still on my computer, I was going to pull up the TBC job and just do a demo of the data being exported from my little survey plan I drew onto Google Earth and falling in the same place. I just wanted to touch on the fact that in TBC, if the scan is georeferenced, all your drawing is you drawing on system, the scans on system, the drawings on system, your CAD points on system, your little pictures or your patterns are on system, your grid line will be on system, everything will be on system. So I was going to demonstrate that, but not right now. I'm not on my computer anymore. Okay, well, guys, thank you very much for the webinar. If there's not any more questions, let me actually hold on. But before I say that, here's all our social media and websites and YouTube, Instagram, Facebook, LinkedIn. Please, please save all of that stuff and visit our website. Follow us on all the social media pages. We put out a lot of promotional videos. There's a lot of stuff that goes out. Our marketing team work really hard on their promo videos and their socials posts. So make sure to give them a follow.